Hi students, welcome to HSC Chemistry and the Industrial Chemistry series. This is number 21, looking at emulsions. In the last video, which kind of hard to know where to end some and where to start new ones, so the other one, I do apologize, went on a little bit longer. I think partly because we do need to cover this idea of emulsions, but we also need to look at the cleaning action of soaps, and the two things pretty much go hand in hand. So I introduced the idea of micelles and how soaps create a bridge, and in this video we'll look at a little bit more detail about what emulsions actually are. So firstly, I guess a quick definition: an emulsion is a mixture of small droplets of one liquid dispersed evenly throughout another liquid. Now this is our kind of definition of solutions, I guess. The difference here is that what we have is two substances which, generally speaking, do not mix. They are immiscible. So if you just left them together, they would separate. Even after agitation, they would separate into separate, distinct layers, with the less dense substance sitting on top of the more dense one. But what an emulsifier does, and soap is an example of an emulsifier, it creates an emulsion of soap and oil in water. So these three substances can all mix evenly together, and so they create a type of mixture which we call an emulsion. So I guess when we're looking at how substances interact with water, there's a number of different ways in which that can occur. What we want to do is we want to try and look at how, for example, the oil and water mixture, which we know would not form a mixture, can actually be caused to do so, and how that manifests itself. Because even within that whole idea of emulsions, there's a couple of different types of ways in which they can manifest themselves. Specifically, the soap itself creates these micelles effectively by the fact that soap molecules have an anionic head, which is good for attracting polar molecules, and non-polar tail, which will link with other non-polar substances through those rules we've talked about before of like dissolves like. So the soap itself can break down these oil droplets into small droplets by their attraction for the hydrophobic tail of the soap. These can still then scatter themselves throughout the water as a series of micelles. So if you consider a little droplet in the middle, and then we've got all these soap molecules with their heads sticking out into the water, and their tails attracting the soap molecules. So this, or the oil droplets, I should say. So this is kind of the structure that we get, and this thing is what we referred to in the last video as a micelle, and there's a whole heap of these. And that's simply because the soap is forming this bridge between the oil droplets and the water. It's not part of your course for you to understand different types of emulsions, this idea of a colloid. It's probably useful for you because you'll encounter examples of different types of colloids in your daily life. But effectively, a colloid is where the distribution is consistent and stable of one substance throughout the other, throughout the solvent, if you like to call it that. But we have unstable types of colloids too, where we get sedimentation. A flocking process can assist that, and also aggregation. And again, flocculants can help do that process as well, which is just bringing the different molecules together so that they start to clump, and either they will remain sitting in the water column, or depending on their density, will either rise to the surface of the interface or will sink to the bottom. You will, in the laboratory, encounter a number of different types of emulsions, and we will look at the emulsive properties of soaps to do this. But some of the common things that you would already know of are things like milk or mayonnaise, which are dispersions of oil in water. So the oil is a substance that's basically being bridged to dissolve in water, which would be the solvent. Cleansing creams are also an example of that. Dispersions of water in oil, so the other way around, are things like butters and margarines and lipsticks and moisturizers, where it's actually the oil that's the base, or the solvent if you prefer, and water droplets that are actually being distributed evenly around. So we can have emulsions of oil in water, and we can also have emulsions of water in oil, and of course other substances as well. The emulsions can be stabilized by surfactants like soaps, so that helps their more even distribution. And there are also some natural surfactants inside the protein casein in milk, and also lecithin in mayonnaise. So these are just some of the different types of common emulsions. And as I said, we'll have a look at a few more of these in the laboratory. Thanks for watching.